Welcome to a lesson with Dr. Powell. Let's look at an example of an optimization problem where we're trying to find the minimum perimeter possible for a particular area. Suppose that our area is equal to um, 8. Okay, and we want to find the minimum perimeter. Now we might be able to guess what that is, but we're going to practice using calculus principles to do so. It's a good little exercise to see if we can actually use a technique that calculus affords here. So now we want to minimize something. What do we want to minimize? Perimeter. That means that's the key. That means that's what the output of the function is going to be or represent. It's going to be perimeter. So perimeter is going to be equal to something. It depends on something. What does it depend on? Well, the side lengths, of course. So it'd be like 2x plus 2w. But we need this to depend on just one variable to be a function. Let's use the other piece of information that we have. The area is equal to 8 to be able, in order to reduce this to just one variable. We know, for instance, that x times w is equal to 8. So w is equal to 8 over x. So we could rewrite our perimeter function as 2x plus 16 over x. And then we can take the derivative. 2, and then we have a minus 16 over x squared. Okay. Now we can figure out where this is equal to 0. We could rewrite this as 2x squared minus, well, not just equal to 0. We want to see where the first derivative changes sign. That's really what we want to see, right? And look at potential issue points. 0 is an issue point. May not be what we want here in the end, but we need to write down all our critical points, the points where the sign could possibly change when we do our sign analysis. We kind of need them all in there, even if they're not going to be the things we're after. Now, the top is actually equal to 0 right at negative root 8 and positive root, positive root 8. You set the top equal to 0 and solve it, you get plus or minus. Now, probably just want the plus part. In fact, this is probably our key. That's probably what we want. But let's do a little sign analysis on this. Notice that at the bottom doesn't really change sign at all. It's always positive. So really the sign really just changes with how the numerator changes sign. That's like a parabola that's going upward. And really these are the points for the numerators. So it'd just be like this, which means that the first derivative is negative over here, positive over here. So for the function, that means decreasing, then increasing, hence a minimum, just as desired. So the minimum perimeter actually happens right at root 8. And we could discover what that minimum perimeter is by working through this. And notice that it's w is root 8 as well, if x is root 8. So it's really just it's a square, just as maybe we suspected. And the perimeter is just 4 times root 8. And that would be the perimeter. Thanks for watching.